Hey, welcome to this guide on LoRa. This is hands-on 1.2, which focuses on the end node. So here's a reminder on the agenda of this guide. We are in hands-on 1, which is the basic network setup, and we are in part 2, which is the end node. This is the network we're trying to set up, and here the purpose of this video is to configure the end node to connect to our LORIOT Network Server through the gateway. So it's this connection here. You remember that the gateway is then gonna forward the data that the end node sends to the network server. So it will make sense, but basically we're focusing on this part. If you're a bit confused, I recommend watching the introduction video of this guide. So I'm just gonna start by walking you through what we're gonna do on this PPT, and then we're gonna do it. We're gonna do it together. So we're gonna go on LORIOT.com and we're gonna click here, simple app. We're gonna enroll a device, and then once we wanna enroll a device, we're gonna need things. So we're gonna need a device EUI, application EUI, application key. And so at this point you might be wondering, okay, where do I get these from? And surely you would know that, you can sense that it would come from our board. So this is the board, right? Somewhere inside there has to be some keys and EUIs, okay? So then what we're gonna do is, so we're gonna install a firmware package. Um, so this firmware package has a lot of examples in it. We're also gonna install this thing for later. And then we're gonna load an example, so the LoRaWAN and node example from the firmware package, which is unloaded. We're gonna load that example on the board. Okay, so we're gonna have the example here. We're gonna connect to the board using TeraTerm. We're gonna connect to the board through UART, and we're gonna be able to see some logs. And in these logs here, as you can see, we have app key, network key, app key, a bunch of keys, right? For instance, we have dev EUI, app EUI, which is, if you remember, what we needed on LORIOT. Okay, so this is why. Okay, so this is why we have to configure this board. We get the keys, and then surely once we put that on LORIOT, it should work. Okay. There are two things here though that are worrying. So the first one is the frequencies. So in the previous video, when we set up the gateway, I don't know if you remember, but the frequency for Australia was 915, 928. But here the frequencies I have are outside of this range, and it is because the region is not set up for Australia. So it doesn't matter where you are, you're gonna have to set up this region. So we will do that. And also here, so the join failed, and this is because we haven't enrolled our device. So I guess your question here might be, how are these things configured in the example? So the next step then is going to be to create our own project based on the LoRaWAN and node example, and we're going to use STM32WL to configure our project. So we will do this together later, but basically we're going to set up the region here and here. We're going to activate the debugger, and that's about it. Then we will generate the code from CubeMX, and we will load this on our STM32WL again. And we're going to observe logs again, and what we're going to see is that the keys remain the same. However, the region has changed, but the connection still fails because we still haven't enrolled our device on LORIOT. So the next step then is to enroll our device on LORIOT. Sorry. But first, before we do that, we kind of want to understand what we've done, okay? Because so far we've used CubeMX, and you will see it's like a graphical way to configure our project. But we want to understand what this has done in the code. So I will show you how to open a .h file, and then we're gonna look at different .h. So here, for example, okay, we'll see that. This is regarding the device EUI. Yeah, so just pause the video if you want to read something. Then we're gonna check the region. So when we set up the region on CubeMX, it affects LoRa app.h and LoRa1 conf. Then one thing that we will have to do manually is actually set up the hybrid mode. So I don't know if you remember, but when we configured the gateway in the previous video, or when we checked the configuration of the gateway, there was something I could actually show you. There was this thing here, the channel plan, AU1 915 channel 0 to 7, and here you can actually, you have many options, right? And so you might wonder, you might have been wondering, what would happen if I selected a different channel plan? Well, I don't fully get it either. No, I mean the main idea is that the gateway can actually work on, I think, all the channels, but the WL cannot. So the WL is going to try to connect on like if the hybrid mode is not enabled, it's going to be trying to connect through all the channels, although the gateway is only looking on channel 0 to 7. But if you enable the hybrid mode, then everything is going to happen here on channel 0 to 7. So this is what we have here, see, channel mask 0 to 7. So basically by enabling the hybrid mode, you're going to make the connection happen faster, whereas if you don't enable the hybrid mode, the gateway and the end node might not see each other straight away because they are looking at different channels, okay? So that's the main idea. So anyways, so we will have to set up this define here, hybrid enable to 1. Okay, so the debugger, this was done through CubeMX, but this is where it is done in the code in system.conf. Then I just want to show you some of the things that you may be interested in the code. So in commissioning.h, LoRa app.h, se-identity.h, there are many variables you can set. So if you want a public network, the default class A, class B, class C, the network ID, the activation type, OTAA, the join EUI, the app key. I mean, you don't really have to know what these things are, but the point is, eventually, when you look for something, these are the .h file you have to kind of skim through if you want to find what you can configure. So anyways, now that we understand what was done in the code, we are actually going to enroll our device on LORIOT. So we're going to go back to this page and we're going to take this information from the logs. We name our end node and then we press on enroll. And once this is done, we will observe that our STM32WL, which is still connected and still running the same code, will finally be able to join our network, and we will have this amazing join OTA message. And now that we have the connection, okay, great. So this is telling you you're connected, but surely there has to be some data we can observe that will convince us that we are actually connected. So yes, there is. We're gonna go on LORIOT, click here on the gateway, click into tap into data stream, and then we will be able to see data flowing, but also the join requests. Okay, so that was a very quick overview of what we're gonna do, and I'm sure you are very confused. But now we are actually going to do this together very slowly. So, what are we trying to do? We are trying to enroll our end node on CubeMX, on LORIOT. you click on sample app here, and then you click on enroll device. And so you have this page, and as you can see, we have to enter a device UI, application UI, application key. But at this point, we don't know what these are, okay? So what we're gonna do now is we're going to configure this board, okay? So this is a STM32WL. And so we're going to open CubeMX. Okay, and then you have to go in here, install and remove. At the bottom, you will find STM32WL, and here you have the list of firmware package. So for this one, there is only one, but if you look at WB, right, you have many versions, right? And so what you want to do is you want to get the last one. So in my case, it's 1.0.0, but for you, when you watch this video, you might have a newer version, so please take the newest version. And then you click on it, and then you click on install now. Once you have installed a new firmware package, this is what you will have under C user, your name, STM32Cube repository. You will have this new thing, which is the firmware package, and which has all the drivers, all the middlewares, but also all the projects. Okay, we will use that later. But first, we also have to install xcubemems1. So just go here, install this thing, click here, and we will use this in hands-on number 2. So then the next step is to open Cube IDE. So I'm using version 1.6.1, but again, please use the latest version. So in order to open a project, you go in File, Open Project from File System. Here you copy and paste the address, the source, and notice how I have STM32Cube IDE here. If I don't have that, what's going to happen is I will have 2 projects, and that's fine as well, but you have to know that you must only select the Eclipse project. Okay, so Eclipse project, and then I click on finish. So now I have my project, and if you go in application, core, you have your main file here. Okay, you have your main file, and that's great. Now what we want is to actually load this on this board. So what I need is a micro USB cable, and I just connect it. There is only one USB here, so it's pretty straightforward. And I just connect it to my laptop. Great. Now I right click here, debug as, tech. Okay, so here you only have to click OK. Nice. So we're now in debug mode, and we want to press resume for the execution of the code to start. Okay. So here the debugger is actually not enabled in the example code, which is why the target stops responding, but that's fine. Now what we want is to actually visualize the logs from our board. So I'm going to be using TerraTerm. So okay, let me show you. So you go in File, New Connection. You select your ST-Link, your board. Okay, and then you have to configure the baud rate to 915 to 100, and you also have to set your terminal. So here I use auto. It's a no-brainer. So yeah, just do that. Otherwise, the logs might like the new line might not work sometimes and you have just weird logs, so just do that. And now if I reset my board, this is what I see. And as you can see, we have some keys and UI here, which is what we needed on LORIOT. Remember here? So this is what we have here. Then we have some information about frequencies here. And as we can see, these frequencies are not configured properly. This is what I was mentioning earlier. So we should be, I'm in Australia, so I should have something around 915 um, megahertz. Yep. And also the join failed, but this is only because we haven't enrolled our device on LORIOT. So the next step then is going to be to create our own new project based on the application we just loaded, but then we will have to configure that project. Okay. So here's what we're gonna do. We're gonna start by deleting this example. So right click, delete. Okay. So don't check this. You want to keep the project. Then you go in File, New, STM32 project from an existing STM32CubeMX configuration file. Yes, that's what we want. Okay, so here I just copy this, I go in Browse, and I want to select this IOC file. So IOC files are CubeMX files. Then I am going to rename my project to WL underscore lab1. I'm going to use the default location, which is in my workspace. So here, click on next and on finish. Okay, so we created our new project, okay? WL Lab 1, and so this should open automatically, but if it doesn't, you just have to click on this file here. And what I'm gonna do here is I'm just gonna clear up my screen a bit. So I'm gonna close this, and I'm gonna close this. What we wanna do is configure our example. So if you haven't used CubeMX before, what you have to know is that this is your chip. So this is the STM32 and all its pins. So each pin can be, you can click on it, you can configure it. And then on the left-hand side here, you have everything you can configure. Okay, so for example, if you go in connectivity, you can have all the I2C, the SPI, blah, blah, blah. Okay. In our case here, what is interesting to us is the middleware and the LoRa1 middleware. So as you can see, many things in this file are already configured, and this is because we loaded an example. But anyway, so what we have to configure first is the region. So what I have to do is I go here in LoRa1 middleware, and I have to select my region, so Australia. This might be different for you, but in my case, it's Australia. And then I have to go in LoRa1 application, and I have to select Australia here. So, yep, very straightforward. Then here, I want to activate the debugger. Tuk. So what I want to do now is I want to generate the code. So first I save, so Control S. Okay. And it will tell me to generate the code. So I'm gonna say no, because what I want to show you is that if I go on project, I can also click here, generate code, Alt K. Tuk. Okay, so the code has been generated. So now what I have to do is to close this file and then I want to open the Project Explorer here. Right click on my project, debug, talk. Press OK. So the build finished, but I don't think it was actually loaded on the board, so I'm just gonna do it again. Talk. Okay. Alright, so we are now in debug mode, and again I'm gonna press resume, but first just want to show you the logs. So if I go in the logs, I can click on edit and I can clear the buffer. Okay, now as soon as I start, as I press this here, this appears, and as you can see I still have my keys and EUI, but I also have my region that has been changed, because before I had something like 800 something and now I have 926, which is within the Australian bandwidth. So that's nice. However, as you can see, it still fails to join, and this is simply because we haven't enrolled our device on LORIOT. And so this is what we're going to do now. Go back on LORIOT, and here you want to enter your device EUI, so this thing here, and you don't want any dash, okay? Then you want the application EUI tag, and then you want the application key. And again, no spaces, no dash, nothing like that. Then I'm going to give a name, STM32WL. I'm leaving this as 1.0.x. Then I click on enroll. And as you can see, it joined the network. So that's great. However, what I want to show you is that if I reset my board here, you will see that it doesn't connect straight away. Okay, it does connect straight away, but that's the demo effect. You will see sometimes, right, join failed, and join failed, right? So because you have a join request every 10 seconds, and here it so happens that it must be trying on some frequencies that are not not channels 0 to 7. So it's just gonna keep on failing, and it will eventually work. Yeah, so it started working, but sometimes it can take multiple minutes. Okay, we don't want that. So what we're gonna do is we're gonna open CubeIDE again and quit the debug mode. So click on terminate. And here you will see that pages move around. The reason for that is because we've switched perspective. So before we were in debug perspective, and now we are in C++ perspective. And yeah, so this is why windows move around a lot like that. So I open my Project Explorer, and now what I want is to walk you through the code and what was changed by CubeMX, and we're also going to do a few modifications. So the first thing is I want you to open seidentity.h. So what you can do is you use the search tool by pressing Ctrl and H. And then you have this thing, you go in File Search, and you search seidentity. Then here you will see that here you have a seidentity.h. If you click on it, you just open the file. If you go on line 92, here you will find this thing, static device EUI. And here you will see that this can be set to two states, either 1 or 0. So if it is set to 0, the device EUI, so the device EUI, quick reminder, is this. This device EUI will be set automatically with the value provided by the MCU platform. And so what is happening is that within the MCU, there is a unique device identifier, which is stored in the OTP, so the one-time programmable memory, at address 0x1ff blah blah blah. And so they take this UI, this UDI, sorry, so unique device identifier, and they put it with the device ID and the company ID, and that makes for a unique ID, which is actually what you have on your board. So there is a sticker on the board here. Oh, there's a sticker here, and this is unique for every board. So this is great because each board needs to have a unique device EUI, and so the fact that you have this option allows you to not have to worry about setting the device EUI by yourself. But if you want EUI, what you would have to do is to set this to 1, and then you could write whatever you want here. Then the next thing I want to show you is the region. So I'm going to open LoRa.h. Okay, so that's one way to open .h file. .h file, you just find it. You find the include in a .c, and then you right-click, open declaration. If I go on line 41, I have this thing here. So active region, and it is set to AU 915. Okay, so I just opened the .ioc to show you the link between the IOC file and the code. So remember, in the middleware here we configured this active region. Well, active region, okay? So before here there was something like EU868. Now I also want you to open LoRa1 underscore conf.h. And what you will find is that on line 45 you have this, and this is what we had here. Then if you go on LoRa1 underscore conf.h, tech middleware, and you go on line 55, you have the hybrid mode. And here it is set to 0, and this is not something that can be set through CubeMX. So you want to set it to 1. Very important. Edit UG 0 to 1. Tech. And then you have many other files you can check. So I'm not going to go through everything. I'm just going to show you this slide again. So yeah, if you want, you can check all of these parameters. Anyways, so now that we have made these changes, I am going to load the code again. And so the only difference we've made now really is we have enabled the hybrid mode, and you will see that the connection will be faster now. Oh, so let's see if it works straight away. Poof, OTA join. I'm gonna reset the board. OTA join. So the hybrid mode is very important. Anyways, so now I've been telling you that the board was connected. We have this thing, but is it really, you know? There must be a way, some kind of data, so that we can see, that we can visualize. And so yes, you can do that. So go on LORIOT, go in the main menu, open your gateway, go into tap into data stream, and now what I'm gonna do is I reset my board. And as you can see, just after I reset my board, I received a join request. And then data is being sent. All right, so this is the conclusion for this video. As we can see, we now have data flowing from the end node to the network server through the gateway. And so now what we want to do is visualize that data. And so we're going to create a dashboard in the next video.